Hello you awesome people and welcome to this lecture. So far we have developed a deployment manifest in such a way that it can read the information from config map. Within seconds these values gets reflected on the container and they start performing its assigned task of web scraping in order to store the output into a text file. In this system there's one problem. The output file is getting generated within the container. Because of this, as soon as the container is stopped, these files are gone forever, which is not acceptable because in Kubernetes system, a pod can crash, a pod can be evicted, and a need for new pod can come anytime, which will be automatically taken care by deployment, by the way. But who will take care of the storage when it is gone with the previously stopped container itself? I am sure you can realize it is high time to think what we can do to not lose these output files. Well, in order to find a solution to this problem, it is good idea to explore the concept of Kubernetes volumes in a practical and stepwise manner. We will try to explore more than one kind of Kubernetes storage option and eventually finalize the one which is most suitable for our requirement. Rest assured, by the end of this lecture, you will have a fair understanding of various storage options you have in the Kubernetes ecosystem. With this introduction, I am sure you are excited for this lecture. Let's get started then. In search of finding a right storage option for our requirement, first candidate among various storage options in Kubernetes ecosystem is empty-dir volume. Let's understand empty-dir and in the end we will see whether it is right choice for us or no. Okay. So what is empty-dir volume? Empty-dir volume is a type of volume that is created when a pod is created and is deleted when the pod is deleted. The empty-dir volume is created on the same node where the pod is scheduled, and this can be used to share data between containers running on the same pod. Okay. With this basic introduction, it is time to try the empty-dir volume ourselves. So let me switch to the manifest file and we'll directly go to, let me minimize the containers for a while. So this is our manifest file. Directly we can go to the volumes. There is already one volume which we created for mounting the config map. I'm sure you still remember the context why we mounted the config map. Yes, another volume we can create at the same place. So this one we are creating for storing our output file. So I'm just saying output volume and then go to the next line, and here I'm pressing Control space in order to invoke the IntelliSense of Visual Studio Code. And here as soon as I type E, it is suggesting empty-dir, means I can hit enter, and empty-dir doesn't have particularly any syntax as such. Okay, it's very straightforward. So if you do not want to customize it at all, you can just leave it like this and your empty-dir volume is created. However, it is good idea to put the size limit here so that size is always in check. Okay, so I've specified the size limit of 500 MB. Good. I'm sure you are not surprised with this at all, that in order to use a volume, you first have to mount it on the container. Then only you will be able to use it inside it, right? So let me expand this container. And here already we have a volume mounted. Here only we can add another volume. So let's say this time the name of our volume is output volume. Okay, and where you want to mount it, mount path is, you can have it anywhere. However, let's say we already have temp directory we are using for our program, right? So I'm just keeping it inside this and then saying it, this name is output. So this will be overwriting everything. So this will be the path where we can expect the output file. Okay. Now mounting our volume itself is not enough. because we have to place our file at this location. So we have to guide our program to place the file at this location, right? Let's do that also in this way. So this mount path we have specified inside the program, and now we can expect our file to be created at this location. Okay, saving it, and it's time to apply this Kubernetes manifest. Awesome, applied successfully. Get the pods. My bad, sorry. I want to connect to the third pod. This is the most recent one, right? So exec minus it, grab the what is our mounted path? Is this temp directory then output? So let me go to temp ls again, and indeed the output directory is created, right? Let me go inside this, and yes, in this mounted directory our file got created this time. So this time this fb.htm file, instead of getting created in the root directory, got created at this location, temp, and then output, which is nothing but the empty dir volume we mounted on this container. Okay, you might be thinking, what is the difference empty dir volume has caused? Because earlier file was getting created in the root directory, now it is getting created in a different directory. That's it. What's the difference altogether, right? Well, the thing is, it depends on who wants to consume this file. If it is you who manually connects to this pod and wants to see this file, then yes, there is no much difference. But we know that a pod can have more than one container inside it. In this case, so far we had only one container. So there was never a question of one container wanting to access the file system of another container, right? But this may not be the case always. So it is high time we try to mimic the scenario where there is another container running in the same pod trying to access this file, and with this empty dir volume it will be able to do so. Let's go for it. So we have to create it at this level. So I'm just saying name of my second container within this pod is going to be file reader container. Okay, image, I'm again going to use the same image which we are used to of BusyBox. Okay, command, we do not want to immediately come out of this container and let it die. So for this reason we have to specify the command, and I discovered there is simple option of making the container sleep for infinite time like this. So basically you need not to put that infinite loop and make it sleep again and again. You can just say sleep infinity. Okay, then we have to mount the volume. So volume mounts to this container, right? Which volume you want to mount? We want to mount this volume, right? So I'll just say okay, now volume mount path I want to keep as this one. And what is the volume which we want to mount? We want to mount this one, output volume. I'm not liking this warning sign, so I'll just put this resources and no constraint. I have created this just to get rid of this yellow line. Okay, now it sounds good. So same output volume we have mounted on the container 1 and container 2. This second container is created within the same pod. Let's quickly understand what we are trying to achieve. Okay, so this volume we have mounted on both the containers. First container is going to write a file in this volume, and second one we will connect and see whether we are able to access that file or no. If this works, it will be a good use case to understand that the containers within a pod are able to access the same mounted volume, right? Okay, let me save this and clear screen, apply this. Okay, so far we were connecting to our container directly like this, but now when we try this, you'll see automatically it has selected BusyBox container, but there were multiple choices available, right? So by default it picked this one. which is not how we want it to be, right? We actually want to connect to this second container. So how we do this is just go here and just say -c, and I want to connect to this container so that it will understand, and hit enter. We are now connected to the second container. Do ls cd_tmp ls, and you can see there is output directory created over here. Let me go inside this ls, and our file is available over here. So with this, it must be very clear that there are actually two containers running within this pod. First is writing this file fb.html into an output volume, and when we connect it to this second container, we are actually able to consume the content available in the output directory. And not just us, if it was some program running on this second container, it would have been able to consume this file as well. Well, this is about empty directory. So precisely, when multiple containers are running in the same pod, empty dir volume can be used to share data between them. Now, it is not the right choice for our requirement, because we want to store our output file in such a way that we can access it anytime, no matter pod is running or crashed or whatever is happening with it. So in this case, empty dir volume will still go down if the pod goes down, right? So data will not be able to persist beyond the pod lifecycle. So this is not our choice, but we have explored empty dir, which is a good thing, right? So in this case, when empty dir is not the right type of volume for our needs, let's consider another type of volume in Kubernetes which can be used to store our files. It is host path. So let's conclude this lecture here and meet in the next lecture to explore what is host path volume in Kubernetes. See you there. Take care.